All right, good morning, Calculus 2 people. So I'm sorry I'm a little late with getting your test preview sorted out, but here's what I'm going to ask you. Okay, the test is only going to be on 9.5, 9.6, so partial, not partial, total derivatives, and double integrals. Okay, so let's go ahead and take a look, shall we? Let's go ahead and do this. There. All right, so let's take a look at this one here. Did I already do this? All right, so there's going to be, mostly I try to come up with like a standard example for a test question. There could be one that's a little off, but for the most part, stuff like this should be, a pretty standard exam. Okay, so that's what we have. So maybe I can find what's a little better. All right. So let's take care of the one that you probably are more worried about is something like this, okay, where we have to figure out, like we have an x, we have a y, we have a z, we have a dx, and a dz, and all sorts of pandemonium going on here. Right? So if we have, we have a 9, so here's my problem. Okay, we have to figure out what is, we can use blue for a while. Okay, so what is dw? Right? So what do we have? We have w is equal to 9x squared plus 4y squared all over z plus 1, right? And what we want to do is we want to figure out, like, what is the total derivative of dw, okay? So that's going to be the partial of w with respect to x dx, it's a partial, okay, plus dw with respect to y dy plus partial of z with respect to z, partial w with respect to z, dz. Okay, that's when you're dealing with a part with when you do a total derivative. Okay, just see the the d, the regular d with a variable. Okay, this one, they're asking you for the partial derivative or the total derivative rather, which means we have to take each partial, right, and multiply it by our dx, dy, dz. All right. So, and in this case, we're going to use what we meant to because they're going to use some numbers in the end. Okay. And this is pretty much how you track like total error in an experiment when you have slight differences in measurements that you have to account for. Okay, so these would all be like measurement errors of what's going on here. Right? So what we have here, right, is we have partial of dw, partial of w with respect to x, okay? Now, when I'm looking at this, I'm actually going to break w up into, we have 9x squared over z plus 1 plus 4y squared z plus 1. Okay, so I want to write it in a way that simplifies it down to where I can see what's going on, right? Now, this first term, the second term, okay, this has no x's. So as far as x is concerned, the partial of x, this term is going to be 0, okay? Now, this one has an x in it, but z is considered a constant. So if I asked you, like, how would you take like 9/11 x squared? We wouldn't do anything with this. It would just be a constant that's multiplied by the derivative, and that's exactly what's going to happen here. Okay, so we're going to have 18x, okay, over z plus 1 dx. Okay, same thing with y. This term is 0. We have 8y z plus 1. Just taking the derivative with respect to y, dy, plus, and then z. So the top part of this, I'll go back to this version of it, the top part of this is a constant. So it's like having a over z plus 1, which is a z plus 1 to the negative 1. Now you can use the quotient rule on this if you really wanted to. I would recommend not doing that and using the power rule instead, okay, in this form. So this is going to be parentheses 9x squared plus 4y squared, and then times, now we've got to deal with the derivative of the bottom. Okay, so I went from these forms to this form because I thought it would be easier to work with. Okay, so that's going to be -1 z plus 1 to the -2, okay, times the chain rule. In this case, the chain rule is just 1, okay, dz. Let's clean this one up a little bit. So we have 18x z plus 1 dx plus 8y z plus 1 dy plus 9x squared plus 4y squared. I'll put a negative out here. That'll take care of this negative here. We have z plus 1 squared. That's what the negative exponent means. Okay, and then we don't really have to put the 1 in there, and then just zz. Okay, now it's just time to plug in our numbers. Okay, we're just going to do that. We're going to say, well, x was -1. Just write that off to the side. Okay, y was 2, z was 5, and then we have dx was equal to 0.09, dy equals -0.02, and dz is equal to 0.03. Okay. So now the only thing left to do here is to plug in our values. So we have, well, what's x? So we have 18 times -1. What's z? 5 plus 1. And then dx, 0.09. Okay. Plus 8. That's right, the 8 from the y times 2. Okay. Again, 5 plus 1. And then dy, this was -0.02. All right. Watching one of my other students do some problems the other day, and honestly, the biggest problem they usually had was they get kind of messed up in the middle. Okay, and honestly, I can tell you the best way to like not get messed up like this, you write the formula down and then you just plug in your values and then just do them one step at a time. Okay, now that was a little bit lower level than what you guys are dealing with, but I noticed that a lot of us make the same mistakes. So this is 18 over 6, 0.09 plus 16, 8 times 2 over 6, and this is -0.02. Okay, -0.02, I should say. Right? Okay. Minus, and then we have -9. Oh no, we don't. We have +9 because -1 squared is positive. 2 squared is 4. 4 times 4 would be 16. And then on the bottom, we've got 36, right? 5 plus 1 is 6. 6 squared is 36, 0.03. Okay. So let's see here. We're going to have -3, 0.09. Okay. 16 over 6. I can cast out a 2 there, so it's going to be a plus 8/3, -0.02, plus, or minus rather, not minus, 9 plus 16, that's 25 over 36, 0.03. Okay, now it's time for the calculator. We'll just get into that. So we have -3. Make sure you use the right negative times 0.09. Okay, so we could write down -0.27 there. Again, it's all of this stuff. You guys are going to be the experts now. I know that's that can be a little intimidating when people are going to come to you with help me with my math. Okay, and I get it, but a lot of what you're going to see is simply people are trying to do too much at the right time, or too much at one time, or they've got some kind of a sign error. It's rarely, I shouldn't say rare, but the most common problems you're going to have to correct with people, or what you're going to notice, like when you're checking their work or seeing how they did something, is really they put in all the numbers in the formula at once, and that's kind of what screws them. Okay. And then we're just going to add all of these pieces up. Okay, so we have this one minus 0.0533.0. 533. Okay, just do it one time, and then minus 0.27. Done. And our partial derivative, or I should say our total derivative is negative 0.302. Okay. Next. I wonder, 4 decimal, oh, I didn't do 4 decimal places. We're not going to worry about it. All right. So, similar problem is number 1. Okay, I'm sure if you could do number 2, it seems to look like a harder problem than number 1, and you'll be okay. That's the level of question I think I asked you for the first problem. Okay, this is the level of problem I asked you for the number 2. It's like here's a a number. You've got to approximate something, and you have no idea what you're going to be doing. I kind of like this problem. Okay, with the there's an x and a y here, right? To see what's going on. Right? So total differential, and then use the calculator to approximate the identity. Okay. So we're going to put you away for a moment. All right, and here we want to estimate. What is this? This is 3.94 times ln of 0.97. Now, what you want to do is you want to round to like the next easiest number, like 4. And then here we want to have ln kind of like 1, right? Which is going to be 0, so don't do that. All right, but I should expect kind of a small number because this is going to be a little negative, right? And then it's going to be close to 0. But what if you don't know that? Notice that these two numbers that I rounded to are completely different. One's 4, one's 1. Okay, the difference is this is 0.06 off, this is 0.03 off. So what we're going to do is we're going to say this is kind of like x ln y. Okay, is equal to my, I like w more, but we'll keep using z. Okay, so our dz, right, our total difference, okay, I don't like it. All right, is going to be the differential for this thing. So dz is going to be equal by, right, dz dx dx, okay, dz dy dy. So here, like my dy is 0.03, okay, because it's 0.03 away from 1. This is my dy. Dx is 0.06 because I'm 6 pennies away from being $4. Okay, so that's what we want to do first. All right. Now, what is the derivative with respect to x of this function? And it's just ln y. Okay, it's just ln y times dx. All right, because the ln y is a constant, the x is just to the first power. So taking the derivative, boom, there it is. Okay, now with y, we're going to say, well, the x is now a constant. What's the derivative of natural log? It's 1, or it's 1 over y, right? The derivative of natural log is 1 over. Okay, and then dy, and this is going to be equal to dz. There's a plus here. All right. And now we're going to plug in our values. Okay, we have x is equal to 4, y is equal to 1. All right, so we have ln of 1, okay, dx 0.06 plus 4 over 1, and my dy is 0.03. All right. Now, if I plug in Well, we'll go ahead and look at that. Okay. So this part here, natural log of 1, you can check me. I recommend that you do. Okay, if you're not familiar with natural logs enough to like just know natural log of 1, oh, by this time you are, but it's okay. Not going to shame anybody. So 0 plus 4 over 1 is 4 times 0.03. So we end up with, okay, 0.12. Okay. So if I'm going to be looking at my total error here, okay, if I just plug this in, okay, we get 4 natural log of 1 plus 0.12. That goes away. I'm looking at 0.12. Okay. I'd really like this to be negative, but it isn't. Okay. And now we're going to look at, what's the actual value? Okay. And our actual value is going to be, what was this? This was 3.96 times natural log of 0.97. So let's go ahead and have a look at that. So 3.96 times natural log of 0.97. Okay, and this was, what was our value? Our value was negative 0.1206. So negative 0.1206. Right? Now for the absolute value, okay, if we take the absolute value of this, we ended up with a 0.1206. We look at the absolute value of this, we got 0.12. So as far as calculating this and getting a reasonable answer, we actually did pretty well. Okay, I would really like for us to have, I really wish the math would have turned out so that we would know what was going on here. Okay, dy. You know what? We did. Because, no, we didn't. Because it's 2 negatives. So even that's going to not work out so well. But yes, it will. Sorry. Okay. These are both under the value I was approximating. So they would actually both be a little less than the value I wanted. So when I plug that in there, we would have gotten that. We would have gotten that. Okay, because this would have been a negative 0.03. This one would have been negative 2, but it didn't matter. Okay, so I'm a little bit happier with that. If I was more careful in how I was setting things up, that would have worked out better. Okay, so usually they ask you for absolute value, stuff like that, so I wouldn't worry about it too much. But just having enough number sense to realize, like, this is going to be a negative number. Okay, because anytime you take the logarithm of a fraction, like, go ahead and try. Take the logarithm of 4/5 or 2/3, right, or 11/16. They're all going to be negative because they're fractions. Well, they're the kind of fractions you would see in 5th grade, right? If you, well, what about 7/6? That's a fraction. Like, yeah, but it's bigger than 1, so it's not going to be negative. See, they need fractions between 0 and 1. All right, so that's how we do that one. Okay. What else did I ask you on this one? I stayed away from these. They were a little difficult to set up, and yeah, we don't get a chance to meet on a daily basis to talk about what the volume of a cylinder is or the surface area of a cylinder, so I kind of tried to stay away from stuff like this. Right? But the other two ones, they are pretty straightforward to set up, pretty straightforward to evaluate. Those are good test questions. All right, I'm going to pause this so I can go to the next section. All right, talking about double integrals here. I'm going to strike fear into the hearts of like any engineer who's had calculus, Calc 3. These are words that will strike fear into their hearts. Okay, double integrals, especially you guys didn't get to appreciate all of this, but there's shapes that are just better expressed in other coordinate systems. Go over and just talk to you a little bit about that. See, we usually do, right? I'll do this. We usually get little, like this is called a rectangular coordinate system because every little block, right, we have a little unit in X, a little unit in Y, and a little unit in Z. And because these are all like straight up and down units, okay, we get like all these little cubes. Right? If I look at X and just X and Y, sorry, X, Y, like if I think about each unit for X's and each unit for Y's, we would end up as a bunch of squares. It's the same thing in 3 dimensions. We end up with a bunch of cubes. But that's not the only coordinate system that we have. Okay, we also have things that would like approximate a soda can. Okay, they're called cylindrical coordinates. Okay, and every time you take a bigger step, you get a slightly bigger cylinder. Okay, so you'll get like the regular, like the tiny little cans that you'll like a tuna fish can, but you can go all the way up to like the industrial size, like mustard, right? Like that, huge cylinders. Okay. And then there's also something called spherical, which is like, just think of like smaller and smaller balls inscribed with each other, or larger and larger balls. So we can get like ping pong balls. And then as we get bigger and bigger and bigger, we're just going to go forward. So you can imagine that expressing a sphere in this coordinate system is pretty easy versus rectangular, and that's pretty much what it's for. Is to be able, it's supposed to make your lives easier. Okay, I would say it kind of made our lives easier. It also kind of made them more of a headache, but that's what the kind of thing that they do. Okay, let's see. Do we get to do that? Okay. I didn't ask you one that was quite as easy as the as this one. Okay, you didn't get anything that easy. But we have, I did ask you a fairly straightforward one. I would go with this one. It might be a little bit harder, but this is a pretty good approximation. Okay, so I don't tell you which one you're supposed to do first. Okay, that's for you to decide. Since they're iterated, this is an iterated integral, right? There's x is bigger than a constant and smaller than a constant. Okay, so you can choose which one you want to do first. It's up to you. And there might be a problem, like that it's better for you to do it one way rather than the other way. But if you find that that's happening, you can always swap the order you wanted to do it in, and that way you'll be able to get a better answer, or I should say an easier answer. Okay, so we have, oh, you guys went from 2 to 2 both times. Brilliant. All right, well, let's go with x equals -2 to 2. Y equals -2 to 2. And in this case, we have 4x squared plus 3y squared. And I will say we have y dx. Okay. So I usually just say dr here, and it's up to you. But let's go ahead and deal with it this way. Okay. So we're integrating with respect to y. Okay. So here's what's going to happen. Is this 4x squared? The 4x squared is a constant, but it's plus, right? So it's kind of like integrating like 11 plus 3y squared dy. You can't just slide this part away, okay? There's going to be 11y plus, right, the integral of, that's going to be y to the third. Okay, technically over 3, there's a 3 that's going to cancel. So this piece here is going to have, it's going to be treated as a constant, but it is going to integrate with respect to y. Okay. So we have -2 to 2. We have -2 to 2. 4x squared plus 3y squared dy dx. Okay. So let's go ahead and integrate. This is going to be 4x squared, this is going to be -2 to 2, okay, plus 3y cubed over 3. Okay, and we're going to go from y is equal to -2 to 2. Okay, just talked about that and I forgot to write it down. Okay, so let's go ahead and see what's happening here. The 3's are going to cancel. We don't have to have a plus c here because we've got limits, okay? And that's good because our plus c would actually leave plus some kind of function that just has x's in it that we wouldn't know. So we took the derivative with respect to y. This is a constant. This is going to be 0. So we don't have this extra complication here. They went regular numbers, so we're going to have limits. We're not going to have to deal with a constant. Right? So -2 to 2. So we have 4x squared, and we're going from -2 to 2 with a y, plus y cubed from -2 to 2. This is where it gets hard for me, though. Okay. So 4x squared, we have 2 minus a -2 for my y's, plus we have 2 cubed minus -2 cubed. Okay. And we still have an x hanging out somewhere. So we have 4x squared, 2 minus a -2, right? Isn't that 2 plus 2? That's just 4. Plus we have 8 minus a -8, right? 2 cubed is 8, right? We have a negative, so 8 plus 8 is going to be 16. Right, 2 to 2. All right, so let's clean this up a bit. Okay, we've got 16x squared plus 16 dx, right? We're going from -2 to 2, right? And now we just go ahead and integrate. So we're going to have 16x cubed over 3 plus 16x, and we are going from -2 to 2. All right, so here we have 16 cubed. We have 8 cubed. Well, no, we don't. We have 2 cubed, which is 8. Right, here we go. We have 2 cubed minus -2 cubed plus 16, 2 minus a -2. All right, it's here. All right, so we have 16 thirds. Okay, we have 8 minus a -8 plus 16 of 2 minus a -2. Okay, so here we have 16 times 16 over 3. Okay, and then we have 16 times 4. Well, 16 times 16, that's 256 over 3. Okay, plus 64. Okay, and then just sorting this out. If you're really paranoid about the fractions, here's what you can do: 256 divided by 3. Okay, plus 64 equals. And now what we're going to do is we're going to go ahead and say math, and then let's change it into a fraction. Done. 448 over 3. By the way, when you're doing these problems, I really want to see like you do, the actual integrations. Okay, that makes it a lot easier to follow, and I know that you know what you're. Well, I can suspect you know what you're doing. Okay, so you want to type out your steps. If you didn't want to do it that way, we'd have 256 over 3 plus 64 times 3 over 3. So we have 256 over 3 plus 64 times 3. What is that? Right, that's 12, 18, 19. We have 192 over 3. So we just add 256 and 192. We get 8, 9, and 5 would make 14, 43, 4. Okay. So we'd have 448 over 3, and there we go. Either way. Okay. I'm not going to, if I came out wrong, I would trust the calculator. At least I would double check did I type the things in right? All right, next. Oops, not that one. Let's see here. Again, I try not to go too hard, but I didn't want to go too easy. So something like this would be okay. if I would put this in here, I wouldn't feel quite so bad about it. So this would be like a hard problem. I could pick something like this, so we'll do it. Yeah, okay. All right, I suspect I picked an easier one than either of the two I'm going to show you, but let's go ahead and look at those. Okay, that would take the edge off and say, well, it couldn't be worse than this. All right, that's worst case scenario here. All right, so use the region R with the implicated boundaries to evaluate the double integral. There we go. All right, so we have dy dx, we have r, and then we have bounded by, we have y is equal to x squared, and y is equal to 2x. All right, so let's draw a little picture. Right, here's y is equal to 2x. Okay. Okay, so just looking at y equals 2x, when x equals 2, y is equal to 4. Okay, and then we'll do the same thing. One of the questions you might have, and it's a good question to have, is where the heck do these two intersect? Okay, so we're going to say we have to set them equal. So x squared minus 2x, okay, is equal to 0. And then notice x is common, so we're just going to have x times x minus 2 equals 0. So 0 factor principle, x is equal to 0, x is equal to 2. Oh, would you look at that? This is exactly the points that we happen to get. All right, lucky guess on my part, I guess. So we have parabola, okay, x squared. All right, x squared is a smaller number between 0 and 1 than y equals x. Okay, you could show that by saying, well, what if x is equal to a half? Right? X squared would be equal to a quarter. So on the line from 0 to 1 for this, x squared is going to be smaller. So between 0 and 1, x is going to be smaller. They don't meet until this point here, x equals 2. So I know that this point is going to be, this curve is going to be under the other one. Okay. So let's go ahead and have a look. Did I not give you a x squared y? All right. So, okay. So what are we going to be doing here? We're going to be going from 0 to 2 because that's our x values here. Right? We'll put our dx all the way out here. We have, what's going on here? We have an x squared to 2x, right? X squared to 2x. We're looking at this volume right here. Okay, so this is 3x squared y, and we're going to hit dy first. Notice when we do dy, we're going to have just x's in, and then we can integrate with respect to x and just get a number at the end. Okay, let's go ahead and integrate. So we're going to have 3x squared times y squared over 2. We're going from x squared to 2x. Okay. Integral 0 to 2. Okay. And dx. Okay. By the way, when you're doing this on your quiz, something I tend to look for is like, did you set your integral? Did you set your boundaries up right? You know, make me a little drawing of like, this is the region I'm integrating over. Okay. If it's just the square, if we're just going from 0 to 1 and negative 2 to 2, we all know it's a rectangle. You don't have to deal with that. But if there's if there's functions down here, do the favor and draw this out, because while I won't be testing you on ones that are like incredibly difficult, this is what you do to solve these. Okay, you solve like, okay, this is the region I'm integrating over. Okay, and then we're going to integrate. So show me that. Okay, so we have a 3/2. We're just going to pull all the constants out. We have integral from 0 to 2, x squared, and then we have, this is y squared, right? So we're going to have a 2x squared. This is y evaluated at 2x, right? Minus x squared. This is x. This is y evaluated at x squared. Okay, we have a 2 here, so these are all going to be squared. That's what that came from. Okay. All right. So 3/2, okay, integral from 0 to 2. And then we have x squared. So let's simplify this one a little bit first. Okay, 2x squared is going to be 4x squared. Be careful of that. Minus x squared. Squared is x to the 4th, right? When you have a power raised to a power, you multiply them. And then we have dx. Okay, let's go ahead and simplify this down a little. Not simplify, but deal with this. We don't want to do integration by parts if we can help it. This is x, this is 4x. 4x to the 4th, multiplying these two, minus x squared times that to the 6th. All right, there we are. Now, integrate from 0 to 2. All right. Now, all we're going to do is we're going to say this is going to be 3/2. Okay. And then we're going to have 4 times 2 to the 4th, okay, minus 2 to the 6th. Okay, this is x evaluated at 2, minus 4 times 0 to the 4th, minus 0 to the 6th. This is x evaluated at 0. Okay, yes, we all know it's 0, but for completeness, we're just doing this to show all the steps to make sure that you're like, wait, what happened with? It's right here. Okay. So 3/2. Okay, we have 4 times, what is 2 to the 4th? Is that 16? Yeah. Minus, and then 2 to the 6th. So 2 to the 4th is 16. Inchworm song, this is going to be 16 and 16 is 32, and then to the 7th power is going to be 64. Not happy about this. Yeah, we're good. All right. 16 times 4 is 0, or 64 rather, minus 64. And that's it, we're done. All right. So, what else would I do, You know what, I messed up. Oh, no, I didn't. I multiplied through before we integrated. I'm okay. Okay. I looked at this and I thought to myself, oh, there's going to be an x cubed. I did mess up though. This should be odd. Right here. Oh, I'm so sorry. Ignore everything after this line. I got so excited about doing all of this, I forgot to integrate. That's not good. I got multiplied and I was like, oh, yay. Oops, no. Let's go back to this line right here. Okay. So we have 3/2. Integral 0 to 2. Okay. Now we have 4x to the 4th minus x to the 6th. So if you're looking at that and say, wait, you didn't integrate. Like, you're right, I didn't. I'm glad I caught that. I'm glad you caught it too. So here we go. We have 3/5, 3/2 rather. And then here we have 4x to the 5 over 5, right? Add 1 minus x to the 7th over 7th. Now we're ready to go from 0 to 2. Okay. I thought that seemed a little too underwhelming as an answer. So here we go. We have 4 times 2 to the 5th over 5 minus 2 to the 7th over 7 minus x to the 5th. This is going to be 0 minus 0. Okay. There's a 3/2 out in front here. All right. This is 4 times 32 over 5 minus, okay, 32 is x to the 5th, 64 x to the 6th, 128 over 7. right? So this is also going to be 2 times 2, so it's going to be 64. And then 128 over 5 minus 128 over 7, 3/2. This one I would definitely, I mean, we could, you know, this is what's going to happen. 128 over 5, we have 7 over 7 minus 128 over 7 times 5 over 5. Okay, that's what we should do. All right, I'm going to have to use the calculator because I'm not going to be able to do 128 times 7, 128 times 5 real easy. So since we're going to use the calculator anyway, what we're going to do is we're going to say 128 divided by 5, okay, minus 128 over 7, right? Yeah, that seems about right. Times 3/2, times 1.5. And then what we're going to do is we're going to convert this to a fraction. We're going to get, see, I still got the 35 here, right? So we're going to have 384 over 35. Okay, and that's going to be our answer for that one. All right. So that's a hard, I think that's a harder version of what I asked you guys to do. All right. Okay, something like this. Double integrated could be evaluated dx or dy first. So sometimes one choice over the other makes the work easier. So let's go ahead and have a look at it. All right. So we have x e to the xy. Okay, now technically you could do these in either order. Okay, we have dy dx. Okay. And we're allowed to change those. And the reason why we're allowed to change is because these are both through, no, these are a rectangle. Okay, so the area you're integrating over is 1, 2, 3, 4, 5, 1, 2, 3, there's 8, and then y goes from 0 to 1. So whatever this shape is, okay, the shadow, if you put a light on top of it, the shadow it makes on the ground is, this is the shadow. Just like in the previous one, okay, if I shine a light over top of it, regardless of what kind of crazy shape the x's and the y's are, if I cast a light right on top of it and shine it into the ground, this would be the shape, okay? You're not allowed to change the limits here. You're not allowed to change the order willy-nilly. You got to do something about that. But this one, it doesn't matter which order you've got this in. Okay. Now I want you to take a look at this. X e to the, we'll say kx. Okay. Because y is effectively a constant if I integrate with respect to x first, or ax. You guys do you remember doing a problem like this at the beginning of the semester? This requires integration by parts. I would like to avoid that if possible, okay, because integration by parts makes everything a little bit more difficult. And by the way, go back and practice that. But if I can avoid it, I will. So what if we do it the other way around? Okay, what if we integrate with respect to y first rather than x? Okay, so this is a maybe. We'll throw that on the maybe pile. Okay, because we can do it. Okay, but I'd just rather not. Okay, so what about trying y first? What if we try x e to the a y? Okay, well, this looks a little bit better. So what we're going to do is we're going to set u is equal to xy and du with respect to y. Okay, the x is still a constant. Okay, so what we're going to do is we're just going to have x dy, right? So we're taking the derivative of both of those. And again, it's a partial, so you don't have to do product rule. Okay. So let's go ahead and recast this. So we've got integral, we've got x e to the, what's my u? My u is xy. What's my dy? My dy is x, or my du rather, right? We have a dy, and we'll have a dx for later, okay? Do we have an x dy in our integrand, like what we're going to integrate? Yeah, we sure do. These two are going to combine, and that's going to be my du. Okay, so we're going to have integral e to the u d. Oh, that, I like this integral. I could do this one before breakfast without having coffee. I like this. Okay, so when we integrate the d e to the u du, that's just e to the u, isn't it? Okay, we have a dx here. We have limits, but we're not going to quite talk about them just yet. Okay, so let's go back to integral e to the xy. What was the limits on my y value? My y value had the limits between 0 and 1. Okay, then we still have a dx, and x had limits between 0 and 8. Okay. So that's how I chose which direction to do it in, is because one of them, the du, ate up the complicating factor of that integration by parts. The thing that made it integration by parts. Okay, it got used up in the du. I don't need to deal with it. Okay, so let's go ahead and take a look at this. So we have y evaluated at 1, y evaluated at 0. We have integral from 0 to 8. Okay, we have x times 1 minus e to the x times 0 dx. Okay. Well, e to the x times 1, that's just e to the x minus e to the 0, right? 0 times x is 0. E to the 0, this 1. Now we're going to go from 0 to 8, okay? And dx. Right. Y's are used up. No more y's. Okay, so integral of e to the x is e to the x. Integral of 1 is minus x, and we are going from 0 to 8. So x evaluated at 8. Okay, we have e to the 8th minus 8 minus, okay, and then at 0, right, we have e to the 0 minus 0. Okay, so here we have e to the 8, right, which we're not going to type in the calculator, minus 8 minus 1. Okay, so this is going to be e to the 8th minus 9, and that is going to be our answer for this problem. Okay, so how long I've gone? Probably long enough, more than long enough. Again, I did not pick something where you would have to chew on it for a while. Okay. I did not ask you an average height. If I had, I would give you the formula for it. Did not ask you for this one where you'd have to get the bounds of x's and y's like this, because that's what this is doing. Okay. Just thought that was probably too long of a question for a quiz. Okay. Now this one, okay. Again, since it is not a region, it's an e to the y to 5, and then a 0 to ln of x for y. Okay. Actually, I don't think I asked you one where you actually have to flip the limits like this. This was too hard of a problem to put on a quiz for this level, so we did not do this. On a homework, it's fine, okay, but on a quiz to ask you to do that, like, hey, I know that it's going to, I know what I'm in for. I know what you're in for. It's going to be confusing, and again, homework, fine problem. Quiz, maybe not so much. Okay, so that's a good one. Something like that's a good one. Something like this one is a good one because this at least like forces you to think like, what's my best plan here? Okay, something like this would be okay. I thought this one was too easy. I thought this one was too easy because that integral was too easy. Okay, this I thought was a good problem. This is a good problem. That's a good problem. Okay, that was a good problem. All right, so this is an excellent problem. Oh no, I didn't like any of these because I thought if you're going to do double integrals, you should be expecting something with just you expect a number, not something with y still in it. It seems a little unfinished to me. Okay, so I did not ask you anything like this. Okay, so that the middle version of the homework for 9.6, that's what you want. Okay, I'm going to leave you with this. I've talked too much, and good luck on your quiz. I know you can do it. Okay, it's not nearly as horrible and as scary as you're going to make it think it is. All right, so we'll start there. Okay.